In our lesson today, toda kuita comparison pie charts. That is what we want to learn. So under comparison pie charts, where do we start? Tinotangira pakuziva kuti pie charts of different sizes are useful when comparing two or more populations. Saka panapa we are using pie charts of different sizes to compare, cannot for comparison, to compare two or more populations. We defined a population in our earlier lessons. A population is simply a set of all observations. Kana kuti a whole set of observations. That is what we refer to as a population. Then of course a sample is going to be a subset of a population. But ndoda kuisa emphasis panapa pakanzi different sizes. How do we determine the different sizes between pie charts? We are evidently going to be considering the radius, because remember kuti ma pie charts maseko, saka we can have ngatiti in two circles. We have this circle and that circle. Chinotiudza kuti maseko aya akasiyana in size. Chinotiudza kuti this is a smaller circle, this is a larger circle. It's the different radius. Saka you should know that in comparison pie charts we are going to be focusing more on the radius. Our next point is going to be the area of each pie will be in proportion to the different population sizes. Saka the area of each pie chart is proportional to the population size. It's proportional to the population size. Okay, that is what we are going to be working with. Trikutora area, tot area is proportional to population size. So if the pies are drawn with radii R1 and R2 and represent total population sizes F1 and F2, then saka in our derivation yatoda kuita panapa tiri kuti the two pie charts have the population tringoreva the number of observations, cannot objects inside that pie chart. Saka they do have two populations, F1 and F2, and two radii, R1 and R2 respectively. Correct, F1 is associated with R1, F2 is associated with R2 respectively, like that. So what is going to happen panapa? Patataura tichiti the area of each pie chart is proportional to its population size. What we mean is we have two pie charts. Let me just put them here. Gatiti, we have this pie chart. Dio in the radius R1, the population is F1. We have another pie chart to compare these two populations. This time the radius is R2 and the population is F2. Saka tichatora the area iriku of this pie chart tovatai seta as being proportional to the area of that pie chart. Saka trikuti area of this pie chart, which is a circle, it's pi R1 squared, and it so pi R1 squared is proportional to the area of that pi R2 squared, and this is equal to tati ma-areas aya are proportional to population sizes, saka this will be equal to f1 f2 like that. Saka we are taking an area totally proportional to that. Saka zvaitika apa hama dzangu ndeizvi zvandoda kuti mucherechedze. Tabatanidza two statements panapa. First statement yedu ndeyekuti pi r1 squared is equal to f1. Second statement pi r2 squared is equal to f2. But toziva kuti these exist in a ratio, therefore these are also going to exist in a ratio. That's why tazodai so. Upabata. That was the influence of that. Okay. So after tanyora this statement, which is a mathematization of what we already know, so atakuchita panapa ndezvekuti since mapi akafanana, pi is a constant, saka pi haichinje irregardless kuti kutilane this pi chart f1 kana kuti f2, saka pi's are going to cancel out. Kurati panapa tichangosara nemaradius. Remember tati chinotiudza kusiyana kwemaseko mapi charts in context maradius. Saka panapa takuti r1 squared s2 r2 squared is going to be equal to the population sizes, respective population sizes. Then of course we take a square root pano and also panapa. To balance off we do the same side kunoku. Saka tadaro manje tenge takuti therefore radius 1 s2 radius 2 should equal to the square root of the population sizes f1 s2 the square root of the population size f2. That statement now is what we use kana tichida kucompare ma populations using pie charts. This is what you should know, but derivation yacho yakakosha zvakare. Okay, saka this statement now we can write it in this way. r1 over r2 takungointerpreta maratio is equal to the square root of g f1 over the square root of f2. That is how it is done. What we want to do now is toda kutora a Cambridge question which we want to use as our practice question for this lesson. This is our question. Question yedu iri kuti the table shows in millions of pounds the sales of a company in 2 successive years. Saka we have a year, first and second, then in Africa, in America, in Asia, and in Europe. Draw 2 pie charts which allow the total annual sales to be compared. Saka if we want to draw 2 pie charts apo, chekutanga tinoda maredai, tinoda futi ma population sizes. Saka what we do here is we first calculate the total sales for each year and the angles in the pie charts. Saka totanga ni first year, we have to calculate the total sales in the first year across Africa, America, Asia, and Europe. Saka for first year, let us call first year population yacho f1. Saka population takati, these are the number of objects are inside objects under study, the whole set of observations. Saka our f1 is the first year. How are we going to calculate the total sales? f1 in here equal to 5.5 plus 6.7 plus 13.2 plus 19.6, like that. Take a add everything with our calculator, we get 45. Then for our second year, let's call the population f2. Saka f2 in here equal to chi, in here equal to 5.8 plus 15.2 plus 9.2 plus 29.8, and add everything, we get 60. That is what we are getting. okay. Saka under first year takuda kuchiziva manje kuti maangles acho akamira sei. Saka let us redo first year angles. How do we calculate the angles? Remember, takati tinotora the particular value, in this case first year Africa, then we divide it by 45, then we multiply by 360. Kureva kuti panapa for the first observation, it's 5.5 over 45 times 360, which is going to give us what? Take a calculator, it's 44 degrees. Then we are going to do the same for 6.7 over 45 times 360, and this is going to give us 53.6 degrees. We do the same for 13.2 over 45 times 360 degrees, and this is going to give us what? 105.6 degrees. And it was a pedzirana 19.6 over the total, multiplying 360 degrees, and this is going to give us 156.8. Take either these numbers, this number 44 degrees, 53.6 degrees, 105.6 degrees, and 156.8 degrees. The total is going to be a complete revolution, 360 degrees. Saka taita ma first year angles, takuda kuita ma second year angles. So it's a lot of work, as you can see. Second year angles. Saka pakuita ma second year angles, the principle remains the same. Africa in the second year, it was 5.8 over, the total is 60. Multiply this by 360 degrees. In our calculator, we get 34.8 degrees. The second observation for America now, 15.2 over 60 times 360 degrees, and our answer is 91.2 degrees. Let us now go to Asia. 9.2 over 60 times 360 degrees. Our answer is going to be 55.2 degrees. And again, then lastly, Europe, 29.8 over 60. We multiply this by 360, and what are we going to get? 178.8 degrees. In like manner, tikatora these values, and we add them, they also give us a complete revolution. Okay, saka tadaiso manje, we now have to work out the ratio of the radii. Those what takuda kuta work out the ratio of the radii. Saka, how do we work out the ratio of the radii? My advice would be mushandise zvataita patanga tichita a derivation. Sa munogona kunyora a statement panapa. Statement yenyu inenge ichiti area is proportional. Saka the area of each pie will be in proportion to the different population sizes. Saka munogona kunyora a simple sentence kuti area is proportional to population sizes. You can write it like this: area is proportional to population sizes. Saka, what do we mean by this? Pi r1 squared s to pi r2 squared is going to be in proportion to f1 s to f2. The pi's cancel each other. We divide by pi on both sides. You know what we mean. Saka panapa zora kuti r1 squared s to r2 squared iri equal to f1 is to f2, like that. Saka isusu we know kuti if we take the square root panapa, we are also going to take square roots apo. Saka this takes us to r1 is to r2. This ratio is equal to the square root of what was f1. F1 tikadzoka kuno taona kuti f1 ndi 45, f2 ndi 60. Saka square root of 45 is to the square root of 60. Saka tadaro manje, what then are we going to do? Tawana that ratio. Okay, so what we can do apo is then to find out what is the square root of 45 and what is the square root of 60, and tikawana these square roots. Saka pano manje zvakuchitika, it's actually interesting. Takuchiti ratio r1 is to r2 iri equal to, this can be written as a fraction, remember, and didn't. Then we go to our calculator, we put that in the calculator as is. Correct chati the square root of 45, the square root of 45, which is dividing the square root of 60. What answer do we get? Answer tinowana panapa, it's, let me write it in fractional form. It's the square root of 3/2, because ndikainyora as a decimal tinenge nchireducer its power, its efficiency and accuracy at the same time. Then root 3/2 inge equal to root 3 s2 to 2, like this. And I want you to remember kuti panapa it was r1 s2 r2. Saka indo ratio yatawana yemaradius kana kuti maredai. It means when we take r1 as root 3, we have to take r2 as 2. Rupaona. And we can actually take multiples of this. Take a multiply root 3 times 2. We also have to multiply 2 times 2. Saka to make life easier panapa, we can do it like this. Then kana tasvika panapa pekuti tina root 3 as to 2, what it means is patinenge takuchidraw ma pie charts, because question yedu iri kuda kuti tidraw ma pie charts. When we do that, zvatinoita for the first year, pie chart redu rinenge rine radius r1. I want you to always remember kuti panapa it's r1 is to r2. Saka our first pie chart rinenge rine radius r1, which is root 3. Saka tinobva tadi taisa root 3 as a radius, then to construct our circle. For our second year, the radius is going to be r2, which is 2, so it's very bigger than root 3. Then we construct our circle like this. Tadaro takuchitanga kuchishandisa ma angles aya tawana for the first year and the second year kuti tichipedzisa our pi. Saka I'm going to leave this exercise to you. Africa, Europe, America, Asia, however it is represented, muchishandisa your math set instruments kuconstructa ma angles are accurate. Once we have done this, we have answered the question. Saka zvese zvataita izvi tanga tida kuwana ma radiuses. Then I also want to warn you on a common mistake. Patinosvika pa root 3 as to 2 panapa, you cannot take the square of both sides, because you are going to change the value of the ratio, because this is equal to 3 as to 4, but root 3 as to 2 yakasiyana na 3 as to 4. Another example yokuti this method cannot be used, the E. Let us say we have 1 as to 2, but panapa pane square root. Saka toza kuti the square root of 1 ndi 1, saka this is actually equal to 1 is to 2. But kuri kuti tanga tatora the square of both sides, like this. Yanga izobuda irichi the square root of 1 squared ndi 1, so yanga izobuda iri 1:4, and yet 1:4 na 1:2 are not the same. Saka please pamaratio apa be warned, you cannot use either squaring or putting the square root. Munotongoti masvika panapa, you interpret it like this. Then kana mawana benefit from this lesson, please consider liking, subscribing and sharing. And if you want to join our class, WhatsApp us on this particular number. Thank you and have a nice day.